this is 2.5 at algebraic proofs. Okay, so proofs are a new concept for y'all. We're starting with algebraic because y'all are more familiar with your algebra rules than your geometry so far, because geometry is still new to y'all. Okay, so we're going to start the concept of proofs using algebra. So a proof is just an argument that uses logic, definitions, properties, and previously proven statements to show that a conclusion is true. Okay, so some of the properties that you're going to use, mostly with your algebraic proofs, are listed here. Okay, the properties of addition, subtraction, multiplication, and division. Okay, you know those. Maybe you didn't remember that they're called addition property of equality, subtraction property of equality, etc. Maybe you forgot that was what the name of the property, but you know what they mean. Okay, when you have an equation, okay, A equals B, you have a left side equal to a right side. Okay, if you add something to one side, what do you have to do to the other side to keep it balanced? Oh, if you add it to one side, you add it to the other. What you do to one side, you do to the other is the rule, right? So it doesn't matter what we add. Let's just use C as an example. So if I add C to A, I also have to add C to B. So if I add it to the left, I add it to the right, and it stays balanced. That is the addition property of equality. That's all it is. And y'all know how to do that. That's moving things across the equation by addition. Okay, subtraction, okay, same idea. If I subtract something from one side, I have to subtract it from the other to keep it balanced. Okay, multiplication, same concept. If I multiply one side by something, so A times C, I have to multiply the other side by the same value to keep it balanced, keep it equal. Okay, now division is the same concept. I'm going to put a slash for divided by, because normally we would write it as a fraction. So we would divide both sides by whatever the coefficient was we were trying to get rid of. And this has an extra step here. It says as long as C is not 0, because you can't divide by 0. Dividing by 0 gives you an undefined. Okay, if you tried to do that in a calculator, you'd get an error. Okay, so that's why that extra piece is there. Okay, but those are the 4 properties of equality that I think y'all are used, you know what you're doing. Okay, that's what you do to one side, you do to the other to keep it balanced. Okay, and when we write these, okay, because a proof is an argument and we have to show what property, we have statements, and then we have reasons. Okay, and in our reason column, every step we do, we have to write the name of the property or the rule or whatever it is, the definition. So you would, instead of writing out addition property of equality, I'm fine if you just write addition. Okay, or if you want to abbreviate property of equality and say prop, like just P-R-O-P period. So I know it's property. Okay, and then you could write of, and you could write EQ for equality. That's up to you, kind of, if you want to write out the entire thing or abbreviate it or just write addition. But you need to know that these are actual properties of equality. Okay. All right, now, distributive property of equality. Y'all know that one. When you have a number outside or a value outside the parentheses, and inside the parentheses there's addition or subtraction, you have to send that value to be multiplied by everything inside, right? So that would be A times B plus A times C. Okay, so that's your distributive property. Okay, or when you're writing it in your reason column, you could just write distribution. That's fine too. Okay, the symmetric property of equality just says that if something is equal, if A is equal to B, then you can flip it around and say B is equal to A. It doesn't matter what's on, if it's on the left or the right of the equal sign, it's the same. Okay, so that's symmetric, property of equality. The transitive property says that if A is equal to B and B is equal to C, then A must be equal to what? What do y'all think? Let's look at this. A is equal to B and B is equal to C. So B is equal to both A and C. So what do you think A must also be equal to? To C. Okay, most of you can just use logic to see it. Well, yeah, if B is equal to both, then they must be equal to each other, right? That's called the transitive property. The substitution property says that if A is equal to B, then B can be substituted for A in any equation. Okay, so if two values are equal, you can substitute them for each other. Okay, that's like if we're told X equals 7, and then we go and plug a 7 in anywhere we see X. We're able to do that because of the substitution property of equality. All right, and then simplifying, that's combining like terms. So when you have like terms on the same side of an equation and we combine them, okay, we would write combine like terms or simplify for our reason. So far, so good? All right, so those are the reasons that we're going to put in our proofs. So we're going to be doing 2-column proofs. So a 2-column proof has a statement in the left column and a matching reason in the right column. Okay, so a statement and a reason. So remember, the statement, that's like your steps in solving. Okay, so I'm going to put that underneath in parentheses. Those are your steps. That's actually showing your work. And then the reason, that's going to be in words, okay? You're going to put distribution or addition or subtraction or whatever it is that you did on that step. You're going to put the word explanation, okay? You can always use for your reason given. Okay, you're always going to start with given. Okay, so the given information is always going to be the first column or the first thing in your reason column. Okay, you're going to start with your given information. Then all of the other reasons can either be definitions or postulates or properties or theorems. Okay. All right, so let's try it with this one. So it says, solve the equation and write the justification in each step. Okay, so this is what we were told to solve, right? So this is what I mean when I say always start with given. The given piece of information, that equation, your reason here is going to be given. You're just going to write the word given because that equation was given to us. We didn't do anything to create that. It was the given information. Okay, or given statement. Now, here's the actual steps, okay? How do they get from -5 equals 3n plus 1 to -6 equals 3n? Where did that 1 go? How did they get rid of that plus 1? They subtracted. So that's going to be my reason, subtraction. They've already got property of equality written out. So from here to here, that was subtraction. if you want to show that subtraction, they did -1 on each side, right? And the ones canceled out over here. That's where -6 equals 3n came from. Does that make sense? Okay, now, how did they get from -6 equals 3n to -2 equals n? Where did the 3 go in front of the n? If you were solving this, how would you get rid of that 3, that coefficient? You would divide. So this is the division property of equality. To get from that line to this line, they used division. And if you want to show that division, you can go in here and you can show divided by 3, divided by 3. That's where -2 came from. -6 divided by 3 is -2. And over here, the 3 over 3 reduces, and you're left with just 1 n. Now, how were they able to change it so that the n was on the left side instead of the right? Look at your list of properties up there. Which one shows that you can switch the left and right? Our list of properties up here. Is that this one right here? If A is equal to B, then B is equal to A. You can switch the order. That's called the symmetric property of equality. So that is the reason that we're able to go from that line to that line. Does that make sense? So you reviewed this process, or you should have reviewed this process in your practice on Friday when we were practicing our algebra skills, how to solve an equation. Okay, you should have refreshed on that. Now we're having to explain each step. We're having to give a reason that we are able to do each of those steps. Okay, so in this one, the statements were all written out. We filled in the reasons. Now in this next one, it's all blank. Okay, that was kind of a guided way for us to start. So now we have to fill in the whole thing. Now, typically with a proof, they're going to be written like this. They're going to say given and prove. So I immediately know my first statement is the equation they gave us. And the reason is going to be what? What did we say that first? Always start with what? Given. Given. That's the reason you start with. You start with your given statement. Okay, that's always what you start with. Then, whatever it is you're trying to prove, that's always going to go at the end. I'm trying to prove that x equals 3. So that should be the last thing on my table. Now, I don't know what the reason is going to be yet, but I know that it should be x equals 3. So I've already got 3 of my 8 blanks filled in just by what was written here. Please don't miss those steps. You know what you're starting with. You know what you're supposed to end with. We just have to fill in the middle. So far, so good? All right. So if I'm trying to solve this for x, what am I going to have to do first? I'm going to subtract 5, okay? So we will subtract 5. What I do to one side, I do to the other. Now, I'm showing this because it's our notes. You don't have to show the actual subtraction, okay? But this is the subtraction property of equality. I'm just going to write subtraction. Now that is going to leave me with 2x equals 15 minus 3x. Now what do I do? Not yet, because I've got x on both sides, don't I? I need to get the x's together. So if I moved the constant to the right, where do I need to move the x's? I need to move them to the left. So how am I going to move that? I'm going to add 3x. And again, you can show this. You don't have to, though. but this is addition, property of equality. So that is 5x equals, and then that's just 15, right? Now, how do I get x by itself? I divide. So the reason that I'm able to get that x by itself is the division property of equality. And again, if you want to show that to be in black, sorry. If you want to show that division, you're dividing by 5. And that's how we ended up with x equals 3. We subtracted, we added, we divided. Does that make sense? Okay, let's flip it over. Okay, so what are you going to start with? What's your first statement here? Good. The first statement is -4 times 22x plus 2 equals 80. And the reason is given. What is going to be my last statement? What's going to go right here? What am I trying to prove? X equals -1. That's the end game, right? That's what we're trying to get to. We don't know the reason for it yet, okay? But now let's fill in this middle part and we can fill in our reasons along the way. So what is the first thing I would do here? This one is a little different than the last one because there's these parentheses. So what should I do? Now, what am I going to times? What am I going to multiply? The -1. I'm going to send that -4 in to be multiplied by just the 22? And both. And the 2, yeah. So what is this called? Distribution. So my first step is distribution. Okay, now when I distribute that -4, okay, I'm going to put what I'm left with, okay, or what I have. So -4 times 22 is -88, and that's my x term, so it's still got an x. And then -4 times 2 is -8, and then equals 80. All right, now what am I going to do now that I've gotten rid of the parentheses? Add 8, good. So that is addition, property of equality. So when I add 8 to both sides, I'll still have -88x equals 88. And then what do? I'm going to divide by -88. So that is the division property of equality. I think you're getting the hang of it. Okay, let's try this one's a little bit longer. Okay, this one says it's going to have 5 steps. My first statement is going to be 3x plus 3 times 5x minus 18 equals 108, and the reason is given. And what is my last statement going to be? X equals 9. Always start with those 3. You can always fill those 3 out to start. Okay. This problem has 10 blanks. You've got 3 of the 10 already. So you're a third, you get at least a third of the credit. Okay. Those are the easy ones. Get it filled in. Don't miss those. All right. So in this one, I see a set of parentheses again. So I'm going to start the same way I started the last one with distribution. Okay, the difference here is there's an extra term in front. This 3x is still there. It didn't go anywhere. Now it's a +3 being distributed. So that becomes positive 15x. And that becomes negative 3 times 18 is 54. So I've gotten rid of the parentheses. Now in the last one, once I distributed, I started moving terms across the equation. Here, I'm not ready to move terms yet because what do you notice on the left side? Yeah, we've got some like terms. There's two x terms. So what am I going to do? Combine like terms. So what does that become? That becomes 18x minus 54 equals 108. Now everything is simplified on both sides. So now I'm ready to start moving terms. So what am I going to move? Yeah, I'm going to add 54 because that's the opposite. So this is the addition property of equality, which is going to leave me with 18x equals 108 plus 54 is 162. And then what do? I'm going to divide both of those by 18. So that is the division property of equality. And 162 divided by 18 is indeed 9. So we have proved, given this statement, we have proved that x equals 9. All right, last but not least, this one's one step longer. This one has 6 lines. Okay, what is my first statement? The first reason is given. What is the statement? It goes in the statement column on the left. Say again? Yeah, that whole kit and caboodle there, that whole equation. So 5 times 4x minus 2 equals 2 times 13x plus 7. Okay, is there anything else I can fill in before I get started? Yeah, that last statement should be x equals -4. All right, so what do I have to start with here? I have to distribute. What do I have? Where do I have to distribute? I have to distribute the 5. Is that the only thing? No, on the other side, the 2 gets distributed. So we've got like double distribution here. So I end up on the left with 20x minus 10. And on the right, I end up with 26x plus 14. Okay, so what do you want to do here? I like to keep my x's positive if I can. If I subtracted the 26x over here, I would end up with a negative, wouldn't I? So I usually move my smaller x. So I'm going to move the 20x to the right. Okay, so when I do that, I am subtracting. Do y'all agree? So this is the subtraction property of equality, which is going to leave me with -10 equals, and then that'll be 6x plus 14. Now I got my x's to the right, so what needs to move next? The -10 doesn't need to move. Yeah, the plus 14 needs to move. So I'm going to subtract 14. So that's the subtraction property again. And that's okay. You can have the same property. It can be used more than once. It can be used back to back. So I end up with -24. I'll do that in black, sorry. Equals 6x. Now how do I get rid of that 6? And divide both sides by 6. So that is the division property So I end up with -4 equals X, and then I just flipped it around. What's that property where you flip it? Flip the order. We used it on the front. Symmetric. For symmetry. So that is the symmetric property to flip it around. Feel okay about this? Okay, I'm going to stop this video. I'm going to give you all the practice.